poke. I poked buttons. What are you talking about? Yes. Abuela, meet Prince Charming.
I'm gonna show up to school one day looking like that, just to see.
Yeah. All right, do the thing.
That's what a lot of people have been saying. Oddly. But
It's a good book. I'm not gonna slide it.
Open notes, open everything, do the thing. Close mouths.
I'm deciding to make him very irresponsible right now. I will not.
Yeah, you do whatever you're gonna do. Number one, you have come.
Have a what?
Watch Star Trek. Get cultured.
Uh,
Why am I being bullied?
Because
I know I'm uncultured. There's a lot of movies I don't watch.
there's a lot of movies I want to watch too, but I
I
just
have to
don't
watch
watch them.
Star Wars for crying out loud.
That one, that one, that one. That one. That one. That one, that one, that one. Right? Not that one. That one, that one, that one, that one. That one, that one. That one. That one, that one. That one. And that one. Cool. Anyone still rolling? Okay.
Hey, morning. You got my test, correct?
It's either in here or Yoast kept it. Last chance. I need to have them in today. Whew. The bevy of bzz, 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 bzz that you hear in the room when you send out an announcement. Okay, it's just that picture right there. So before we get going, I'm kind of running through this with all my classes because, you know what, the last few years have been interesting. We had some misconceptions about math, or what classes were offered before that, and then everything went to hell, and now it's even worse because, yeah. That is our math pathway. If you are in here, you are at PreCalc. You've got all the snarl behind you. So you don't have to worry about that. It's a matter of what do you want to do with your life? Okay. Once you hit PreCalc, again, we are past high school curriculum. It depends what you want to do. If you are a junior and you are registering for next year, it depends. Are you headed to a STEM field or not? If you are headed into a STEM field, science, technology, education, and math, engineering and math, sorry. If you are headed into a STEM field, I would say register for Trig and Calc. If you are not, take your ACT immediately after this class, and if you know you are not headed into a STEM field where you are eventually going to have to go on to Calc or higher, then just do dual credit, college algebra, and stats, and you are done with math for the rest of your life. Okay? Like, get them done now while it's fresh in your head, and you can get the easy A out of it, is what I'm saying. If you are a sophomore and you are registering for next year, I think you're on Thursday. Junior year sucks. Like, you ask the juniors, you ask administrators, counselors, teachers, junior year is rough because there's so many requireds. There's this pressure to do a bunch of AP classes. Like, it's rough. Okay. Senior year, you only have 2 requireds. Everything else is whatever you want to do, just to make sure that you got your requireds for a diploma out of the way, and then whatever pathway you want to take. If you're a sophomore, I would say spread out Trig junior year, Calc senior year. Don't murder yourself with math unless you know you're headed into a STEM field. If you know you're headed STEM, then Trig and Calc next year, dual credit Calc 1 for the easy A because you've already done calculus, and decide whether or not you want to go dual credit Calc 2. Okay? Like, that's the only reason you would do Trig and Calc as a junior, dual credit Calc 1 and 2 as a senior. You know you are going to mines, you are going to be an engineer, not just because your parents told you should because you're good at math, but like, this is what you love. That's the only reason you should do that. Otherwise, spread it out. There's plenty of tough classes. There's plenty of ways to challenge yourself. Go do debate. Go do physics, bio 2. If we have a speech and debate classes, get multiple years of foreign language. There's a bunch of ways to challenge yourself without just burning out on math. Okay? So if you are already in pre-calc, you are in one of those 2 positions. Do we have any seniors in here? I thought I had 1 or 2. Okay? Uno. All right. You're in here every day at lunch anyway. We need to talk about what we're doing at the end of the semester because y'all get out a little bit earlier. Every year I've got a couple of seniors, and we got to decide how you want to roll with Chapter 10 or not. So, okay. But anyway, that's a thing. I just sent it out to everyone on Remind. Go ahead, share it with any of your classmates or what all, just because like I said, I had a kid last semester who was in Algebra 2 having never taken geometry. We have kids who do pre-calc and then college algebra because that's what the guidance office told them. Or we have kids who take college algebra so they don't have to do pre-calc, thinking that counts for their 4th year of math for the Regents Scholarship, and then they tell them, oh no, you have to take college algebra and stats to qualify as having your 4th year of math. So like, there's just misconceptions. I want to make sure, there it is. From Math Guide, that's what math is. Okay? So, there it is. Just like I would not, don't ask me what to do for your English classes. I don't know. Take the ones with words in them. So, here you go. What is a something to the 6th power that goes into 128? 64, 2 to the 6th, right? So I rewrite that as 6th root of 2 times 2 to the 6th, or 64, whatever your jam is, times, I also want to break this up. I'm going to say y plus 2 to the 24th, because that is something to the 6th. And then a y plus 2 to the 4th is left over. Everything that is to the 6th gets out of radical jail. 24 of them bum rush the guard, but only 4 make it out. It's like Jet Li's guarding the jail or something, I don't know. 6 of them rush the guard, only 1 gets out. Everything that's left in there stays in there. What I want you to be careful about is do not, I know that we were able to reduce these on some problems yesterday. That only happens when you can reduce everything. Remember, math is communist. What you do for one, you do for all. I can't call this 3rd root of something squared because I can't also reduce this power. So that's just my answer. 2 y plus 2 to the 4th by 6th root of 2 y plus 2 to the 4th. Absolute value or not? It's an even root, but an even power. So whatever y is, this is going to be positive. It's fine. Please tell me you didn't try to distribute into that. Remember, that's not y plus 2. That's 4 y plus 2's. I don't distribute a 2 to all 4 of them because they're all broken up by multiplication. I would only put it into one of them. What did you do to your foot, child? When did that happen?
Oh, it's Saturday?
Did I just completely miss that yesterday?
No, I didn't have it yesterday.
Oh, okay.
I got it checked out last night.
Listen to the doctors. You've heard this before.
Yep.
Listen to the doctors. Anytime I see a kid with the boot, the space boot, the crutches, anything like that, I chew them out. I did not listen to doctors. This entire foot is made of wires and screws. It hurts like hell every day because I didn't listen to doctors. Okay, it's all just scar tissue. When I walk, every now and then I'll just collapse and fall down. It's because scar tissue got caught in the joint and it tore as I was walking. Listen to doctors. Take care of yourself, boy. All right. Over here, I'm going to rewrite both of these as powers of 5. That's 5 to the 4th, and then the 1/3 power of that. So I can just call it 4/3. So whatever stages you took in that. 625 is 5 to the 4th, so then 4 is numerator, 3 is denominator. Or you take 5 to the 4th to the 1/3, multiply your exponents. Either way, I get there. And then 5 to the 3rd, 1/4 power. And whenever I have a fraction over a fraction, I subtract. I'm going to need common denominators though, so I'm going to call that 16/12 and 9/12 is 5 to the 7/12, which I write as the 12th root of 5 to the 7th, or the 12th root of, don't ruin this fries for me, hold on. 525, 125, 625, 31, 25, 75, 15, 625, 75, 31, 25, 78, 125. Either one works. Okay? No, I don't care. Do either one. So pointage, here's how we're going to roll. I'm going to say 2 for this guy, 2 for that guy, meaning you have some work to back it up. We can see what you did. You got the process, you got the final answer, and then we're going to leave 1 floating for the oopsie. The oopsie is usually, I distributed 2 into this.
What if
I forgot my 6 root and just left it as square root.
What if I did distribute, but I had like the actual answer written down just earlier in my work?
And then after that, you called it 2y plus 4 to the 4th?
Yeah.
I got it. I got to take 1. I got to take 1. If you're going to simplify, simplify correctly. It's like clank off the foul post. Any other questions about it? Remember, it's not just questions about the homework. It's not just questions about the process that we're doing about this. You can also ask questions about how do I score it. I'm not sure if this is a 3 or a 4. Ask. We are always going to learn from I screwed up. If you ever watch old episodes of Mythbusters, failure is always an option. Okay? I learn from mistakes. If you don't learn from mistakes, you are doomed to repeat them. You've all heard that before? Case in point, World War II, rise in dictators and fascism. As soon as all the people who witnessed World War II die, look at what happens. Rise in global fascism. You have all of these countries that used to have old people being like, nah, dude, don't do that. I have seen where this goes. Don't do that. Well, they're all dead now. So they're not able to tell people, don't do that. So people are doing it again, right? If you make a mistake, don't be afraid to say it in class because we can learn from it so that you don't make the mistake again later. So someone else in the room doesn't make the same mistake. Okay? The first caveman that chased a skunk into a hole and was like, I'm going to eat that kitty that got a stripe. Wow, that's a fun smell. He never chased a skunk again. He learned from his mistakes. Okay? Or he did it anyway because he was desperate. So, homework. I had a kid before 8:02 ask me, what does X4 mean? I had someone ask me at like 8:05. Okay.
So for 8, I got 4I, but I think that
I is specifically with square roots. This is just going to be a negative because it's an odd root. Yep. If you ever see X4, it means every fourth. X3, every third. E is evens, O is odds. Okay. No, I will never assign you 20 plus problems. Ever. I think the biggest assignment that I ever give is like 10 problems, and then that's fairly easy ones where I just need like one of each kind because they were all different types. You will never have an assignment that big. Okay. Oops. Oops. Okay. It was fairly easy stuff though, right? Okay. But no, you should not have an assignment that long in my room ever. Most of the time I try to limit it into that 5 to 8 range. Like just a handful of problems, one of these, one of those, one of those, one of those. Here's an application. That's all I want. Just a little bit of independent practice. So, questions about the actual math? Okay, go away. Yes, go away. Womp, 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 womp. Okay, we left off, you were the class that did not get to 3 variable, right? We got everything else, not 3. Cool. I don't know. We're about 10 minutes off. Not much. We're only about 10 minutes off of the other class. So, 3 variable systems. The idea behind it is you eliminate a variable two different ways. The most important part about this is it's the same variable. Don't eliminate an x one way, a y the other way, and then try to work with it. Because now you have literally made square peg and round hole. It's not going to work. Okay? Instead, what you want to do is eliminate a z. Okay, now eliminate z a different way. You don't do it the same way. Don't use the same two equations, or else you end up with the identity every time. So maybe I'll use equations 1 and 2 the first time, and then I'll use 1 and 3 the second time. Okay? Two different ways. Once you do that, you now have a two-variable system, which we already know how to solve. If I get rid of z and then I get rid of z again, well, I now have two equations that only have x and y. Solve that. Now you know x and y. Go back and solve for whatever variable you eliminated. Okay, 3 stages. Eliminate a variable two different ways, then go solve your two-variable system, then go back and find the thing you got rid of. Now, I know what I do in my classes. I don't know about the other classes. Do they really show you substitution method with this? Most of us are going to gravitate towards elimination with this, but you can do substitution. I had a kid last semester who was dead set on this was the only way they were going to do math. In that case, I would call x is 2y minus z plus 15, and I'd plug it in here and here. Distribute, combine like terms. Now I'd have two equations that only got y's and z's. Solve that. Then go back and find x. But didn't you still find a way to eliminate this x? Two different ways. Okay, so this part, you do it however you're going to do it. I am always going to do it by regular elimination because that's my jam. That's just how I do things. That doesn't have to be how you do things. Okay, so first, x minus 2y plus 15, 2x, 3y minus z is 7, 4x, 10y minus 5z is negative 3. Okay, step 1. This process is going to be garbage without a little bit of organization. You've all done the problem where it took up half your page, you get to the end, you check your answer, it's wrong, you go to look back in your work and it looks like a pencil vomited on your paper. I have no idea where I went wrong. I can't even read this. I am now going to start over. Let's put some organization to it. Not only will it help you, but it means you can compare with other people. It means you can send a picture of what you're working on to me, and I can follow your steps. It means I can follow your steps on your test and give you partial credit when you missed a negative on the very first line and everything after that is trash. You remember three variable systems from Algebra 2, right? How many times did you accidentally call that x plus 2y on the very first line and your whole system is wrong? It happens. I want to give you the credit, so that means I need to be able to follow your work. So I can eliminate x's, y's, or z's. I can take first row times negative 2, knock out this guy. First row times negative 4, knock out that guy. Second row times negative 2, knock out that guy. Add these two together, straight up z goes away. Top row times 5, add it here, that guy's gone. Y's are a little dicier. I could take this times 5 and get rid of this, but then nothing else is really a compatible factor. So maybe I'd have to do 3 times equation 1 and 2 times equation 2. It involves more work, so I'm going to avoid getting rid of the y's. I ask you, what do you prefer? Knock out z's or x's? Okay. You got that, kid, right? So if I'm going to get rid of z's, I'm going to start by actually writing that. Equation 1 is x minus 2y plus z is 15. Equation 2 is 2x, 3y, minus z is 7. That'll knock out z's. The other way we said was 5 times equation 1. So right, 5 by equation 1. So you know, how did you get from here to here? And 4x plus 10y minus 5z is -3. Okay, this is what we referred to in Algebra 2 as Magical Christmas Land. Magical Christmas Land is the thing that only happens in Hallmark movies. Reality does not look like that. I ended up eliminating a variable 2 different ways, but I also, along the way, happened to eliminate another variable. Purely by accident, purely coincidence. Doesn't work out that way every time, but it was nice. In set 1, I got 3x plus y is 22. Set 2, I've got 9x, bye-bye, is 72. So you see how if that still had a y, you would just have your two systems with xy, xy, or your two equations. Now that I have that, I'm going to make my two variable system of 3x plus y is 22. If you want to divide along the way, you can. But I'm still writing what I'm doing, right? I'm showing you where that came from. You should be able to follow. It'd be like Madden's football play from hell by the time you're done. There's arrows and stuff going every which direction. But you can see where it's going. You can see where it came from. You can see what happened along the way because the instructions are written along the way. And now if x is 8, well, 3 by 8 plus y is 22. Subtract 24 over, y is -2. Who what? Just ask. Come on. Ask it! Be not afraid. Oh, I just divided by 9 along the way. Instead of having 9x equals 72 here and then dividing, I just did it on the road. Okay. I don't have time to eat breakfast in the morning, so I eat my Jimmy Dean sandwich on the way into school. Right? On the way there, I got her done. That's it. Like, I can throw it in a microwave. I can stuff it in my pocket as I'm walking out the door with goblin number 1. Okay. I now have x is this thing, y is this thing. I eliminated a variable 2 different ways. I solved my 2 variable system. I will now come back around in a full circle to figure out what z is. I'm going to use equation 1 just so I know where I got this from and say x minus 2y plus z is 15. And I will plug in there 8 and -2 respectively. 8 plus 4 is 12, subtract. Z is 3. And then, cherry on top, I'm going to write it as a 3-dimensional coordinate, 8, -2, 3. 3-dimensional coordinates are still written in alphabetical order. There's my 3 steps. Step 1. Eliminate a variable 2 different ways. Step 2. Solve your 2 variable system. It might be easy like this. It might have a little more oomph to it. Step 3. Go back and solve for whatever you eliminated. And this is how I typically set mine up. So it's just this big loop. That is my organizational method. It doesn't have to be yours. Okay? But anyone in this class should be able to pick up your paper and follow your math. You see along the way, I've got arrows showing me where I'm going. I've got the equation numbers next to them so I know what they are. I have what I did to the equation to show how I got there. You have to organize it or else you will get lost. Y'all remember 3 variable systems from last year, right? Or last semester. Sometimes you get lost because there are just too many moving parts. Okay. So we're going to start with baby steps. Okay, that was the example. The practice is actually 2 ahead. When I say start baby steps, we're going to go over to number 27 here. Why might this be considered baby steps?
The variable's already eliminated one.
One of my variables is already gone. So since I already have an equation where y is gone, go eliminate y again. And now you will have 2 equations with only x and z, and you can head on down the road. Okay? Get them. I see a couple of you doing it. It's a good idea. If I don't leave enough room there for you to write, do it in a separate notebook. But then next to this in your notes, just star it and say in notebook. And make sure you label it in your notebook so I know where to find it. Okay? Some people just write big. I write small. I know I don't leave enough room in my notes all the time. Remember, daily quizzes, I want you quiet, do your own thing. This, I want you chatting up your neighbors. Make
You can't plug this back into this one. It's a new. It's like.
Says who?
Well, I did it and I got 0. I got
Yeah.
it to be 0.
Zero. Zero's a number 2. Stop hating. Over here throwing shade at 0. 753 335 115 115 cancel 2 510 0 yes 05 050 gone 52 -2 a whole box of fidgets over there, too. Take whatever you need. Alphabetical order whenever we have a three-dimensional, yes. X, Y, Z. Eliminate a variable another way. Y was already gone, so I'm going to eliminate Y again. I now have two equations that don't have Y's. I have a two-variable system. Solve the two-variable system. X is 5, Z is 0. Every year from Algebra 1 all the way up through PreCalc, I have kids who will get to Z equals 0 and they think it's just no solution. Okay? Just Z is 0. 0 is a number. And then come back to the beginning, go find a Y. I'll use equation 2 because it's a positive Y value. 2 of these plus Y plus 1 of those is 8. Those things are 5 and 0 respectively. Getting 10 plus Y is 8. Y is negative 2. Write your system. 3 variable, X, Y, Z. 5, negative 2, 0. Again, your steps. Eliminate a variable two ways. Solve your two variable system. Go back and solve for whatever was eliminated. Bam, bam, bam. Okay. Now, I said this one's got the training wheels on it because one of them already had something missing. Dang, round 2. 7, 5 cancel 6, 1, 6, 1, 9. 5, 6, 1, 9. Negative, negative, negative. And 1, 6, 1, 9, 3. 6, 1, 9, 3 of those, 3 back. 15, 17, 17, 3, 7, 5, gone. Oh, cool. 17, 3, 12, 17, 6, X is 1. X is 1, 6, 1, 9, so 3, 1, 3, 1, 3, 6, 7, negative 2, 2, 1, 3, 2. 1. 3 is 2. 2 plus 2 is 4. 1. 1, 3, 2, 1, 6, 7. 7 minus 2, 5, yes. 1, 3, 2, 1, 2. 2, 9, 11, minus 6, 5, yes. No question mark. No question mark. I plant my flag on that one. And you're not finding any rares in here, right? Oh,
Don't think so.
okay. Then, as you're going through, if you find any of the ones with the sleeves on them, just take those off. Put them in a pile somewhere. Okay, looks like most of us are getting there. Finish up the last parts. Or no, we'll put it down here. Stage 1. I label equation 1, 2, and 3. So I know what the crap I'm doing. Who got rid of x's? Like your first goal was get rid of x's. More of an outside of class thing. What about y's? One got rid of y's? The cheese stands alone? Did everyone else get rid of z's? Yeah. Okay. It all works, right? If I get rid of x's, take this times -5, bam. Take it times -2, bam. Take this times 2, gone. Take this times 3, gone. Most of us are going to gravitate towards z's because I see a coefficient of 1 and -1. It's just less to do, right? If there's less to do, run with it. So if I take equation 1 and equation 2 and just smash them together, 5x minus y plus z is 4. X to y minus z is 5. And probably 3 times equation 1. 15x minus 3y plus 3z is 12. Equation 3 is 2x plus 3y minus 3z is 5. First one I get. 6x plus y is 9. Second one. Coincidence. We get 17x is 17. Okay. One of those magical Christmas land ones again. Now that I have those, I go get my two variable system. Maybe this time I won't do anything on the road. We'll say 6x plus y is 9, 17x is 17. Then I'll solve. Divide and get x is 1. 6 by 1 plus y is 9. Subtract 6, y is 3. And then I know what x and y are. I'm going to go back and find z. I'll use equation 1 because it's got a positive z value. That's just my personal preference. Doesn't have to be yours. I plug in what I know. X is 1, y is 3. Get 5 minus 3 is 2, plus z is 4. Subtract, z is 2. Write your coordinate. Well, and get my 3 stages. I'll eliminate a variable 2 different ways. Solve my 2 variable system. Sometimes they're easy, sometimes they're not. Go back and solve for what was missing. 1, 2, 3. Okay. Nice, neat, and organized, so you can tell what's going on. Sometimes they're set up for substitution. Okay, not all the time. But if something is set up for substitution, that means somewhere along the way they said variable equals stuff. I told you what that variable is. I don't have to rearrange anything. I don't have to divide by something, maybe get fractions, maybe have to do a whole bunch of distribution. Instead, it's just ready to roll. This usually happens with word problems, actually. The word problems will be something like, you charge $10 for t-shirts, $20 for hoodies, and $50 for jackets at your roadside stand. You want to have twice as many t-shirts as you do hoodies. Well, that just said this equals 2 times that. Bam, ready to go for substitution. Okay, so they'll do that sometimes. If I said that R is stuff, well, if R is this stuff, replace R with that stuff, right? So I have 5 times R minus 4S minus 3T is 3. And we just said R is 3S plus 1. Now I'm leaving a blank in there because I also have here T is S plus R. R is 3S plus 1. So T is 4S plus 1. Well, if T is that, then go replace T. Okay. R is this stuff. Go put R here and here. T is this stuff. Go put it here. I have replaced R and T with R replaced in it. Now I got an equation that is all about S. Disturbed. 15S plus 5 minus 4S minus 12S minus 3 is 3. Y'all remember maybe all the way back to like algebra half? Every time you run into a plus or a minus, it's a new term. Remember seeing that kind of stuff? Like way back in the day, ancient magic. Just sort your boxes, sort your Legos. Okay. I also have a inclusion algebra and algebra half. 15 S's minus 4 S's is 11 S's. 11 S's minus 12 S's is negative S. 5 minus 3 is 2. Negative S is 1, so S is negative 1. And if I know what S is, then I can come all the way back here and say R is 3 of that thing plus 1. T is 4 of that thing plus 1. I now know what that thing is. It's negative 1. Getting S is negative 1. R is negative 3 plus 1. T is negative 4 plus 1. And someone in the audience starts twitching. Because it wasn't 1, 2, 3. Who's that kid? It's like, it's almost there. So can I just swap those? No. Okay. Sometimes you have ones that are just set up for substitution. They don't have to happen. They do not happen often. There you go. Words are hard. So, one last time before we go on to section 6. Show me what you're working with. Everyone's like, I got this. All right. I'm going to start writing things and wait, what? What's wrong with it?
They're not.
They whack. Okay? They are not written in standard form, so you need to put them in standard form. Go 2x plus 4y plus 3z is 6. X plus 2y plus z is negative 5. X minus 3y minus 2z is negative 7. Ah, crud. I don't want to do it all. Screw you, Frank. Get wrecked. Yes. Do the thing. Where'd Black go? Is Black still over there? Black's still over there. Okay. You should do the problem. You already did the problem. Oh, good job. Okay, now you can check my mental motor then. All right. Negative 1, 1. 1, 3, 2. Negative, negative, negative. Cancel, cancel, cancel. So 5. 5, 2. 5, 9, 9, 3. Negative 1. Negated. So minus that is 2. So plus that is 4. So 9, 4. 12, 18. 9, 4, 18. 18, 1. 1, 3, 2. That's a 0. 1, 2, 2, 0. So 5, negative 4. Question mark?
You're right.
It is? Sweet. Okay. Are you winning, son? I am because you asked, Dad. I said everyone's going to work at a different speed. Like, if you got the thing done, then why sit here and be bored?
No, he got his phone calculator out and he had the calculator right.
Oh, okay. Oh, that is a super random thing. Where are the chosen ones? Who here has an iPhone? Sucks to suck. Who has an Android? Yeah. Free TI-84 emulator for all Androids. Just Google it. It's called Wabbit, like Elmer Fudd, Wabbit emulator. WABBIT. It is free. You can, but you got to pay for it, or they're the free ones that don't have all the features that actual TI-84 does. And so when we start doing nonlinear regression, you're screwed. So it's either pay or get not all the features. Okay. Also, Apple is notoriously crabby about their proprietary software, and they do not allow a lot of apps on there, whereas Android is open source, and you can get all kinds of good stuff for free.
Yeah.
Oh my gosh.
Okay, looks like we're either there or we're finishing up, so I'm going to get started on mine. Curious who did what? Who eliminated X's first? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, all right. Y's. Who eliminated Y's first? The cheese stands alone. How about Z's? 2 of you? 3? All right. Majority rules. I'm going to go with X. And say equation 1, 2, 3. If I take equation 1, x minus 2y plus z is negative 5, and negative equation 2. So negative x plus 3y plus 2z is 7. I think that's actually what I was doing too. Y plus 3z is 2.
I think you wrote the wrong number. You have
What?
1 and 2.
Oh, 2 and 3. See, I can do the whole thing in my head, but I can't write basic numbers.
Brownie point.
Yes. Better. Okay. Seriously, that do all that? Can't write numbers. Mm, I'm curious. Did anyone do 2 minus 2x's minus an x minus an x?
I did not.
2x's minus an x minus an x is gone. Anyone?
Did you do that?
Yeah.
I didn't.
It's perfectly legal, right? If this is a teeter-totter, that's teeter-totter, that's teeter-totter, you're all balanced, can't we put all 6 of you on this side and all 6 of you on that side and it's still balanced? Okay. It's a thing. Okay, so after that, maybe... did you use equation 2 or 3 to knock out the top? 2? Okay. So I'll say equation 1, 2x, 4y, 3z is 6, negative 2, equation 2, times the negative 2 is negative 2x, times the negative 2 is 4y, times the negative 2 is negative 2z, times the negative 2 is 10. Womp. And cancels. 8y plus z is 16. Again, I eliminated a variable 2 different ways. I now have a 2-variable system. I can solve this 2-variable system any number of ways. I can multiply the top by negative 8, knock out y's. Multiply the bottom by negative 3, knock out z's. Get the y or the z by themselves and solve by substitution. You've got all of the above available to you. I'm gonna bottom row by negative 3. Y plus 3z is 2. Negative 24y minus 3z is negative 48. Negative 23y is negative 46, so y is 2. Go back and plug it in. 8 by 2 plus z is 16. 16, 16, z is 0. Go back to the original, plug them in. Y is?
Say it.
No, it wasn't a question.
But y is literally one of our question
No,
words.
Y is.
Oh, okay. Messing with me? Then go back and find one of the x's. Either one of these works. I'm going to use, I don't know, equation 2. X minus 2 of these plus 1 of those is negative 5. Those things were 2 and 0 respectively. So I get x minus 4 is negative 5. Add x is negative 1. Eliminate a variable 2 ways. Solve the 2-variable system. Eliminate or solve for the thing that was eliminated. Womp. There it goes. Okay. Same process every time. It's going to come back to us in chapter 6 when we do it by matrices. So we don't have much time for 6, but 6 is really easy. 6 is actually all the stuff you learned back in Algebra 1 because you were supposed to use it in geometry and then you didn't. Oh, we can turbo this. Y'all remember doing half regions? Please. 1/2 x minus 3, so it's like that. And this one is negative 2x plus 7. So like meh. They're both solid lines because more ink here, more ink there. And then you determine which way to shade. Depending whether you did linear programming in Algebra 2 or not, determines whether you learned the little arrow trick or whether your graphs were just really messy. To determine which way to shade, A, I can jam in a coordinate, check if it's true. If I put 0, 0 in here, I get 0 is less than or equal to 7. That's true. So I shade everything to that side. If I put 0, 0 in here, I get 0 is greater than or equal to negative 3. That is true, so I will shade towards that point. I always encourage my kids to use these little air traffic controller arrows, because otherwise what happens when you lightly shade this way and lightly shade that way and then darken the living crap out of it here? What happens when you light highlighter this way, light highlighter that way, now it's kind of tinted in the middle, darken the living crap out of it? Or did anyone do the cross-check thing? Where it's like, what am I on, blue? And then you get the waffle, shade the waffle. What happens when you have 3 or 4 or 5 of these? Gets really messy really fast. So that's why I encourage kids instead of that to do the arrows, because you can just say, well, where are they all shading? Where are all the arrows pointing to? Okay. There. This one was something like meh and something like meh. Except, uh-oh, less ink here. They're dotted. Okay. So I'm just quick sketching those. Please make sure they're actually like a slope of 3. This one says another way to find out which way to shade. This says y is literally less than the line. This says y is greater than the line. So if y is less than this line and greater than that line, there's nowhere they overlap, no solution. Don't shade both parts and then say no solution. Just don't shade anything, because there is no solution that is going to satisfy both regions. Okay, so just turbo through that because, y'all, that's algebra half. Speaking of algebra, matrix operations. A matrix is just an organization of data by row and column. Row by column. Okay. You should have seen it in Algebra 1. You should have used it in geometry. I know you didn't use it in geometry because I've been asking them for 7 years to use this in geometry and they won't. So this particular matrix is considered a 3 by 4 matrix because it has 3 rows, 4 columns. An element in the matrix, if the big matrix is capital A, every element within it is a sub row by column. Especially our juniors ought to know in here a subscript. doesn't mean mathematical operator. A subscript tells me which one. A sub 2 means the second A. You first saw that back in algebra half again with y sub 2 minus y sub 1 over x sub 2 minus x sub 1 slope formula. It meant your second and first y and x respectively. So this thing right here, because it's in row 1, 2, 3, column 1, 2, 3, 4, because it's in row 2, column 1, I would call that element A sub, little a. Bad Sullivan. I'd call that A sub 21. Little a, because it's an element, not the entire matrix. Sub 1, because it is row 2, column 1. What's the negative 8 that it's pointing to? Little a, because it's an element in matrix A. Row 3, column 2, element sub 32. The row, column, square, and zero matrix, if you can't figure that out by context, what are you doing here? Right? One row, one column, square because it's 2 by 2, zeros because, well, okay. So, matrices are just used to organize your data. Can you tell me the stuff? What are the dimensions of this matrix and which element is A sub 13? Down there, example 1, that matrix, what are its dimensions? What is element A sub 13? I'm concerned about the overheard, I've never seen this before. That's not good. Algebra 1, and you should have done a bunch of it in geometry. I know our geometry teachers aren't using it like they should, so all the way back to Algebra 1. Okay.
Do you have Miss McGill? Yeah. Yeah. You had green wall, that's probably why you saw it. I got it right.
I just saw it this last time.
Okay. There. It's a 2 by 3, 2 rows, 3 columns. Value of A sub 1, 3 is row 1, column 3, negative 18. Okay. The reason we needed these to organize our data was to make all of your transformations in geometry easier. If I want to add and subtract matrices, it's nice and simple. You add and subtract the corresponding elements. So if I take A plus B, well, row 1, column 1, row 1, column 1. Row 1, column 2, row 1, column 2. Negative 5 and 6, 14 and negative 23. Okay. Now the catch that you want to write next to it, though, is you can only add and subtract matrices that are the same dimensions. Because if I take B minus C, I'll take 12 minus 2, 10. I'll take negative 7 minus, crap, there's nothing there. No, you can't just go throwing in a 0 because you feel like it. The matrix is contained by those brackets. You cannot just throw something onto the matrix and hope it sticks. If you could, maybe there would have been a better plot line for the remake. Okay, since I can't do this, then I just say B minus C does not exist. You cannot make it. Yeah. What you learned back in Algebra 1 was scalar multiplication. Scalar multiplication is literally just distribute. Okay? I distribute 3 into all the stuff, saying negative 18, negative 9, 21, 36, and negative 45. I don't see the need to do that again. All you need to say is distribute. Okay. That's it. You just distribute. That's what scalar multiplication is. Okay, multi-step operations. This is why you should have learned them and should have used them. Y'all remember, blank space, whatever. If you want to write it, you can. You don't have to. Y'all remember that? Remember how long it took you? You would plot triangle ABC. You would move those coordinates up to. Write those coordinates. Move it 3. Write those coordinates. Reflect it over the line y equals x. Write those coordinates. Dilate it by a scale factor of 4. This is what you were supposed to do and what I keep asking them to do. Row by column, X, Y, A, B, C. When you move everything up 2, you are adding 2 to all of your Y values. When you go left 3, you are subtracting 3 from all of your X values. Both of these combined turns into 4, 6, 8, negative 2, 0, 2. Reflect over the line y equals x. Swap your x's and y's. Dilate from the origin by factor of 4. 16, 24, 32, negative 8, 0. That's where ABC quadruple prime is. My geometry classes, we usually got through the entirety of all transformations in 3 days.
It took us
A month?
2 months.
Yeah. So, rainbow meme, the more you know. This is why you were supposed to learn matrices. This is what you were supposed to do in geometry. It was this idea of a multi-step process. If that says 4 times the quantity P plus Q, well then good old PEMDAS, please execute my deranged adolescent sister, still works. Parentheses first, add them. Add their corresponding elements because they're the same dimensions. Then take whatever you got times 4. Go. It's mental math. 3 plus negative 4 is negative 1 times 4. It's arithmetic. Matrices make everything so much easier. Now, I know a good chunk of you also had geometry during the shutdown, so you were just screwed in every way possible. The rest of you probably had Algebra 1 during the shutdown and never saw matrices in the first place.
Negative 1, 3, 5. 2, negative 5.
Okay.
3. It's 13.
Yes, it is.
Pop-Tarts in the cabinet, $1 in the jar. Game Club appreciates your business. Cool?
Yes.
All right. Stay with me. I don't care what the clock says. Stay with me. Okay. Solving a matrix equation, the way that the book wants us to do it, the way the old school books were telling us to do it, was to actually write those matrices in that place. I'd say 4x minus blah equals blah. And then I would add blah plus blah. That's a lot of writing. Instead of that, I'm going to use the concept we just finished with and literal equations from algebra half. How about I solve for x? We don't divide. We multiply by the reciprocal. Could you now take this plus this divided by 4? There you go. Which was exactly how we were supposed to do transformations. I would add this way, subtract that way, because that's how I do my translations. Then a dilation by 1/4. Okay, so I would take negative 9 plus 5 is negative 4 times 1/4 is negative 1. Is 8 divided by 4. Is 12 divided by 4. Is 16 divided by 4. Is 0 divided by 4. Is negative 8 divided by 4. They make all of this arrangement of data so much faster, so much easier. Now, yes, I can multiply a matrix times a matrix. We will actually get to that in Chapter 6. It is technically an Algebra 2 standard. You haven't seen it yet. We will get to matrix by matrix. They involve some thinking. We'll just leave it at that. Okay, the very last thing, stay with me. Don't you at me. Okay. 1, this book is horribly outdated. Back in the ancient times, you used to have to pay for every single text message that you sent. You had so many minutes on your plan. You were allowed to call that long, minus nights and weekends and anyone in your network. Imagine, I want you to think about every single message that you send on any platform, text message, TikTok, Snapchat, Instagram, all of it. How many messages do you send in any given day? Okay. Typical teenager, I'd say you're looking at least 100 to 200. Total messages, every social media platform. Okay.
Is this sent and received or just sent?
Both.
More.
Because it costs you to open them too. Now I want you to think about that, and it cost 10 cents for every text you sent. 75 cents for every picture you sent, if your phone even had a camera. Okay? It was not uncommon for kids who were irresponsible to rack up $20 to $50 a day. This was in the times before you saw the running total of usage, before there was an app for it, before your parents could throttle your data, before they could change that. Imagine you're racking up $20 to $50 a day, and they don't know until they get the bill at the end of the month. But y'all, tables are just matrices. That's it. That's what this is. Okay? I already said it. Juniors, that's what you're doing for math. Sophomores, you got a little more complicated route next year because you got to decide what you want to do with your life.